Hey, what's up, guys? This is Chung. So today, let's talk about one Codeforces problem, engineering Artem. So there's like this engineer who is trying to build a new robot, and and he has like this 2D matrix, right? And with n rows and m columns. And if the two adjacent cells contains the same values, the robot will break. So that's so the purpose of this problem is we need to try to avoid, we try to make like a 2D matrix uh, whose adjacent where every adjacent uh, number is different, and we can make a slightly change for this board by following these rules here. Basically, for each of the cell, we can either choose to increase the value by one, or we don't increase the value at all. That's why this is why more formally, we need to find a good matrix B that satisfies the following condition, assuming the A is the original one. So this one basically is telling us the same thing, right? So for each element of the B, it could be either the same as the original values, or it could be the values, original value plus one, which means that we could increase the current value by one. And after this one, after some like operations, right, we need to make sure this 2D matrix uh, is a good one, which means that there's no adjacent cell that has the same value. Cool. So and here's the inputs, right? We have T test cases, and then after T test cases, the first one is the N, second one, the next one is N and M, and then there are like three rows and two columns, right? That's that. And yeah, to solve this problem, actually this is kind of interesting. I would say it's a little bit like brain teaser. So let's try to draw a few examples, right? Uh, I mean, normally, right, when we try to think of like a board, right? Let's say we have a board here. It doesn't really matter how big it is. I'll just draw a few, maybe a 4 by 4 board. And let's say this is the current cell, right? We're trying to check if there's a number here, right? There's like maybe the number is 4 here. So we want to make sure, I mean, there's no adjacent value, right? Who has the same value as 4. I mean, a naive thinking will be maybe we can try to I mean scan the cells from top left corner to the bottom right corner, and every time we only compare with the above one and the left one, and if there's one difference, right, and then we just we increase the current one. Otherwise, we just leave it I mean as is. But I think that will not work. So why is that? Because let's say let's say the four is right here, 4 is here, and when we try to process the previous one, right? Let's say we have mm, let's say there's a 4 here, and uh, this one is 5. Okay, here are different values. 4, 6, 9. It doesn't really matter, right? 10, 10, something like this. So if we process the values, I mean the cells one by one, right, following a sequence, I mean, so 5, none of them it has difference, so we'll keep them the same. But when we reach this 4 here, right? So if there's a 4 and 5 on the left and right, we cannot basically we're stuck here because 4 is different, is the same as 4, but we can also increase the this current 4 to 5 because that will be a conflict with this one. So which means that we need to find like a better approach so that we can make sure, there's no adjacent value has the same values. So I think the tricky part for this problem is that, hmm, so so what is the neighbors? We have four, right? This one, this one, this one, and this one. And so for like a 2D matrix, if we separate if we separate those kind of cells into two groups by the parity. So if we do a I plus j, we check if this one is even or odd, basically check its parity. So for odd, if I plus j is odd, sorry, is even, right? Then what are the cells for the even I plus j? This one. Okay, I'll use square. Okay, this one, right? This one, this one. Uh, maybe I'll use a different color. This is better. So we have, right? So this is the odd, the even, the even index, I plus j index, right? Right. So this is the even I plus j, and on the contrast, right? The I plus j is odd. For the odd one, right? It's basically the rest cells. So as you guys can see, so now this parity, the I plus j, the parity of I plus j, basically it split this board into two different groups. And each of the groups, right, it happens to be basically with the current values, right, the odd neighbors it happens to be the other parity cell. So with this kind of features, so all we need to make sure is that, I mean, the easiest way to make sure there's the neighbors is different as the current one is that we just need to make sure the parity, the value of the parity of each cell's number, the value is different. Basically, assuming, right, we're defining, right, all the blue one is even number, and the rest is odd number. As long as we can make that we can guarantee that one, right? Because an even number can never be the same as an odd number, vice versa. And also an odd number can never be the same as even number. So as long as we can make sure the current number and all its neighbors, the parity is different, then we definitely we make sure that we find like a good matrix, right? I think that's it, right? That's as simple as it is. So all you need to know is that, the neighbors, right? The parity of the neighbors and the current value, basically the I plus j's parity of the current value of the current cell and its neighbors is different. That's all you need to know. And as long as you know that, the rest is pretty straightforward. And yeah, so I mean for coding, I mean it's pretty straightforward, right? So we have t test cases. I'll just quickly write that. The codings right here. So we have n and m, right? And then we read the n and m. So for int I in equals 0 and I plus plus, right? And then I just loop through the entire 2D matrix m j plus plus, okay? And then we just read the numbers, right? Int numbers equals that, and you can do anyway. Either way is fine. In my case, right? I'm checking this one. Basically, if the I plus j divided by 2 is equal to 0, right? If this one, if the for the even I plus j, right? I'm making sure. Okay, did I? Okay, I think I missed. I check if the current one, is a if this one is an even number, right? And I just do a num plus. Basically, for all the even I plus j parities, I'm making sure that the current number is an odd number. You can either do an odd or even. That doesn't really matter. As long as the first part and second part, the even and the odd is different. That's all it matters. Else, right? Else, if the number and this if the current number is an even number, right? And then I just change it to odd number, basically. Sorry. If the current number is the odd numbers, I change it to even number. And above, if the current number is an even number, I change it to odd number. So that's why in this case we can just we're sure that the parity of the I plus one I plus of this the I plus j is different for those two different groups, right? And then here I just output num. Yeah, here just like the output, and then for each of the rows I also do a count of the end out, right? To just to break the line. Yep. Yeah, that's it, right? I'm not going to run the test cases because based on our logic, right? This one will get a different output, but this approach will pass the test. Yep, I think that's it, right? I mean, um, just like a little bit of observations, right? As long as you can find the patterns, right, for these neighbors and the current values, the rest should be pretty straightforward. Yep, I guess I'll just stop here and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.